Start.
Thank you very much, Professor Singh. So, namaste. Namaste. It's a pleasure to be in this conference. So, first of all, I would like to thank to all organizers, especially esteemed Professor, my dear friend, Professor Dr. Mangeiran, for organizing this conference. It's a pleasure for me. And it's very nice to see you, Professor Singh, again. Okay, let me share my presentation. Okay. Okay. Can you see this? Is it visible?
Yes.
Yes, sir, it is visible.
Okay, let me turn it full screen. Okay. So, yeah. So, again, thank you very much for inviting me to this conference. My presentation will be on the use of decision-making models for sustainability and circular economy. Thank you for the information, Shristi, for introducing the topics that I'm working on. Thank you so much. So let me try, yeah. The slides are changing, am I right? Okay. Okay. So I have come up with this wonderful view of the university. So I just wanted to put on my presentation. Okay, let me skip. So I can skip this short biography. And sorry. Why doesn't... Okay. So, you know, nowadays, me and, my dear colleague who was the previous speaker, Professor Sachin Kumar Mangla, who we are closely working together for many years. And we are working on sustainable and circular economy. Especially, we are trying to build or develop models of circular business models for various different sectors, especially from the supply chain perspective. So in that sense, when we are trying to contribute to this transition of circular economy and sustainability, this adaptation or implementation of sustainability requires decision-making stages. This is for managers, this is for policymakers. So these are not easy decisions, and it has a multi-objective perspective, like economic perspective, environmental perspective, and social perspective. So in that sense, we need certain decision-making tools and methods to assist those decision-making stages. And when we think of the supply chain perspective, again, we come up with the reality that we have so many stakeholders that we should take into account. In that sense, we have increasingly complex business models. And on the other side, of course, much more complex globalized supply chains. So, in that sense, it's inevitable to choose among different number of options. So where the importance of decision making arises one more time. So in that sense, we can use different models, but today I will try to mention a couple of them, maybe not all of them that we are currently using, but mainly multi-criteria decision making methods that we have applied on our certain studies that I can share with you. And I will try to show the applicability of MCDM, and most probably there might be young researchers today who are with us. So maybe I can a little bit shed light to the question of when should we use which method. So as I'm going to share with you the application of these papers or studies covers a wide range of industries, from food supply chain to ship dismantling, from e-waste to logistics, reverse logistics, especially for the sake of circular economy, from cement manufacturing to textile industry and even to the energy distribution. So in that sense, these studies embrace the topics of forecasting, product process design, disassembly line balancing, supply chain design, urban mining, reverse logistics, and of course their combination with Industry 4.0 and digitalization. Okay. Okay. So some examples. These are not the all methods and models that we are using, but some of them that I'm going to share with you today. So first, of course, we should focus on the research question. What's our research objective, and followed by research questions. So if we are dealing with risk, which is an important phenomena that we have seen very closely during the COVID pandemic, that has significantly disrupted global supply chains. But even before that, we were studying risk management and risk management issues. So one or two methods that I can suggest to our friends is the fuzzy synthetic evaluation, and especially todim fuzzy todim. If we are trying to reveal the causal relationships about topics, then I would suggest fuzzy Demattel method, ISM, interpretive structure modeling, fuzzy version is also possible, or system dynamics. If we are dealing with forecasting, there are a bunch of many forecasting methods, but in chaotic situations where the data is not so reliable or difficult to collect, then grade prediction, and in ranking situations, for ranking perspective, then I'm going to suggest two methods with some related papers with fuzzy Mura AMP and fuzzy AMP. Of course, there are many others. Especially what we are doing is we are using our industrial engineering operation research perspective background for the sake of sustainability and circular economy. Of course, we have studies on by using simulation. Nowadays, we are working on AI, machine learning, ensemble learning, NLP. Plus, of course, we are using more classical methods of mathematical modeling, multi-objective optimization. But for today, I just wanted to share these methods. So the slides are changing a bit slowly. Sorry for that. I don't know why. Okay. So Demattel, fuzzy Demattel, ISM, fuzzy ISM. If we are working on a quite new topic, if we are not sure of the relationship between those variables, then in order to reveal those causal relationship affecting factors or driving factors, which are the cause factors, which are the effect factors, which are the driving factors. So it is nice to apply these methods. Okay. So let's start with this example, using emerging technologies to improve the sustainability and resilience of supply chains. So actually today we see the reality that we shall not work on a simple single topic. So what we see the reality of resilience, we see the reality of adaptation to the changing circumstances, but on the other side we have the sustainability issue. So in that sense, we need to combine those topics of sustainability and resilience. But on the other side, we have the emerging technologies in a wide range of technologies we have seen. So which emerging technology would be used in which situation? So in that kind of analysis, again, first we may need to reveal those relations relying underneath those topics. Okay, so this was a similar case in automotive industry. So in that sense, today I would like to also mention several sectors that are rising and quite important in terms of sustainability and circular economy. This was in Annals of Operation Research. As you're gonna see on those papers, we are working very closely with scientists from India, like Professor Sachin Kumar Mangla. And some of them are also outcomes of projects that we have conducted with Turkey and India, and with Turkey and UK under Newton Fund research funding. Again, an important topic, food supply chains. Food supply chains are also very important because they are so vulnerable to disruptions, and of course we have seen the so vital and important aspects of food supply chains during COVID period, especially on Europe. When people have seen empty shelves, they have understood that it's not the prosperity or it's not the amount of wealth in the bank, but the reality is the food that we cannot survive without. So in this paper, we have assessed the impact of COVID-19 on sustainable food supply chains. So we have approach from food safety, security, know-how transfer, logistic networking, risk mitigation, employee commitment, traceability, and responsiveness categories, especially in food supply chains. As you may guess, the important thing is the trust. So for trust, we should have transparency. For transparency, we should have traceability. So for traceability, we need to have tracking. So as you see, information sharing, know-how transfer is quite important, and we have tried to identify those issues by using interpretive structural modeling, ISM. Okay, next one. It was in Sustainability Journal with colleagues from UK. Sorry. I think I will skip those. Okay, sorry. Can you see those slides now? I think it would be better for me to use this version, so I can skip. Yeah, I can change slides easily. Okay. So, in the, okay. So in this one, it was about ship dismantling, which is an important sector, I know, for both Turkey, India, Pakistan, Bangladesh, that it's an important sector, even though it has some environmental impacts. So in this one, we have studied design for sustainable ship dismantling. So we go back to the product design phase, even though when we call a ship as a product, it might be quite ironic, but at the end of the day, it's a product. So we have studied with engineers, designers of those ships, and so we studied material selection, design, and life cycle assessments, standardization of parts, modular design of those ships in order to make life easier at the ship dismantling stage. It's an important sector, and even though it has some drawbacks, but can be rectified by using appropriate measures, and not only to environmental impact, but also to employee safety. There are certain vital points. So it was published in International Journal of Shipping and Transport Logistics. Yeah. Then we have studied resource melioration in emerging economies for urban mining, which is quite essential topic all over the world, especially from e-waste perspective. In that sense, we have used again fuzzy dematel in resource policy to reveal the barriers in order to apply urban mining and resource melioration. In this paper we have in RCR, it was published. Even though we are talking about most of the time digital technology, these are perfect. We have also studied a lot, but there's behavioral factors underneath, relying underneath the adoption of sustainable supply chain practices. So we studied those behavioral factors for footwear industry. Another one, again, ship dismantling. We have studied, this was another paper on the same topic. And then we have studied cement industry. Also, one of our joint PhD students today will present his studies on cement industry, for circular cement industry today in this conference. It's an important sector, especially for emerging economies. And in that sense, we have used how shall we adopt green supply chain within cement industry. And in this one, workforce 4.0, we are talking about industry 4.0, but most of the time we are neglecting the human side, human aspect. And in this paper, we have tried to shed light on workforce 4.0, which was like 4 years ago, but at that time it was quite important. Nowadays, it is much more important. Okay. So those were the papers that we have used, mainly ISM, fuzzy ISM, dematel, or fuzzy dematel. Let's discuss a little bit on AMP, analytical network process. So it's also quite important when you are using a set of criteria in a network manner, and their relations is also quite important. Especially this paper is focus on synchronized barriers. So when you're facing with concurrent or synchronized transitions, like companies today are going through a transition of circular economy, at the same time industry 4.0 and digital transition, and they do not have the luxury to say that in the next 3 years we're gonna complete the digital transition and then we can look at the circular transition. That's not possible. That should be conducted simultaneously. But when you have that kind of a necessity, of course, your barriers are synchronized barriers at the same time. So how should we overcome those barriers? So in that sense, to be honest, that in emerging economies, we shall not say that it will be a direct jump from 3.0 to 4.0. It will be, most of them, it will be 3.5, what we call. So we studied those barriers, for synchronized barriers for those concurrent transitions. We are talking about operational excellence, but from green supply chain point of view, what are the operational excellence with an environmental management perspective, which was published in BSc. I also strongly suggest young researchers to combine operational excellence with green supply chain phenomena. System dynamics is frequently we use it as not for micro, not for macro, but what we call for meso analysis. It's quite important. In this one, we have studied system dynamics to analyze societal impacts of blockchain technology in milk supply chain. For example, here we try to focus on food supply chain, one of the most vulnerable parts of the supply chain, milk supply chain. The use of blockchain technologies as a member of, we can say, Industry 4.0 family, but for the sake of societal impacts. So again, it's a phenomenon that has been unfortunately neglected compared to environmental side. The societal part is also very important, I strongly suggest. And we see this also in sustainable development goals. So also like safe food, good health and well-being for everyone. And we have used Stella software in those studies. Next one about air pollution. We have used this to assess the environmental management of cement industry in streaming data context. Unfortunately, also in my city, there are factories and there are certain regions where cement industry is located, but they suffer due to certain air pollution. We approach not only from cement industry, but we combine from some macro level data, and we have tried to make a anticipation, a forecast for the air pollution, including carbon monoxide, nitrogen oxides, and sulfur oxides. And then gray prediction is another important technique I strongly suggest if the sector, if the concept that you're working is under chaos. For example, in Turkey nowadays, we see this chaos in red meat and also milk and dairy supply chains. And this was a study on red meat supply chain with circular economy. And also we made a similar thing for milk, for dairy supply chains. This one is about e-waste, electronic waste, that we have used for the proposing digital collection and classification centers, which are essential. Unfortunately, we are focused on collection, but that's important, definitely. But what these results have revealed that according to Gray prediction, the necessity of digital collection and classification centers are as much as important as not only collection, but classification centers are essential. Fuzimura, another MCDM technique we have used for disassembly line balancing. We are talking about e-waste, so then we should talk about disassembly lines, but disassembly lines cannot be studied under just improving the productivity and decreasing cycle time. Definitely we're gonna try to do it from engineering perspective, but at the same time we should take care of the hazardous operations and worker safeties during disassembly operations, especially when you think of disassembly operations in e-waste, or more specifically in batteries. There might be really hazardous operations, and also environmental impact is also quite critical in disassembly line balancing. So we approached from that perspective. Okay, let's decrease the cycle time, but with taking into like a multi-objective manner, do consider environmental impact like leakages and other problems, and also worker safety, operational safety. Oh, sorry. And when, as I have mentioned at the beginning of my presentation, if you would like to take into consideration the risk management, which is quite essential, I strongly suggest fuzzy synthetic evaluation or TODIM, fuzzy TODIM. These are important, and like resilient reverse logistic operations. So our logistics operations should be reversed for the sake of circular economy, but they still should be resilient. So we cannot sacrifice from the resilience of reverse logistic operation just because we are doing them for circular. Should be reverse, but should be resilient at the same time. And unfortunately, these are more prone and vulnerable because in reverse logistic operations, the uncertainties are much more than in linear economy. In linear models, still we have uncertainties, but when we are talking about closed loops or circular economy, the uncertainties are much more greater. Why? Because we have many new stakeholders, and this brings uncertainty. In linear supply chains, we try to forecast demand, but here we need to forecast the life cycles. The consumer perspective is involved, collection site is involved, so uncertainties doubles, maybe triples sometimes. And TODIM, which was based on Tversky-Kahneman prospect theory, and again we use it on sustainable disassembly line balancing. I strongly suggest if young researchers are interested, they should study prospect theory. Even though it was generally used for behavioral finance, it has significant impacts on operations management, can be used on supply chain and operations management. And due to the lack of time, I just tried to mention the names and where we can apply. But for more, of course, you know, the ones who are interested can reach me or my co-authors. Thank you very much. I hope I have used time efficiently as much as I could.